We want to sketch the following rational functions, and the first one we have is y is equal to x over x squared minus 16. Now remember, we can write that as x over x minus 4, x plus 4. Now, if x is equal to 0, y is equal to 0, and y equals 0 would only happen when x is equal to 0, and we find that by looking at the numerator. So we know that it goes through the origin. From this form here, we can see that we have vertical asymptotes, and those would be x equals negative 4 and x equals 4. Now we could see if it has any turning points by differentiating. So u is x, v is x squared minus 16, so du dx is equal to 1, dv dx is equal to 2x. So dy dx is going to be v du dx, so that's x squared minus 16, take away u dv dx, so that's 2x squared, all over x squared minus 16, all squared. So dy dx is equal to negative 16 minus x squared over x squared minus 16, all squared, which we could write as the negative of x squared plus 16 over x squared minus 16 all squared. Now we can recognize this as a quadratic which won't factorize in the reals, so we can say that dy dx is never equal to 0. So we have no turning points. Now, what we could also do is look at the signs of the function in various regions. So let's think about what the function is made up of. We have x plus 4, x and x minus 4. So this one here changes sign at negative 4. So we'll look at x being less than negative 4. We'll look at x between negative 4 and 0, which is where this one changes sign. Let's look at x between 0 and 4, where this one changes sign, and then x more than 4. So if we're less than negative 4, all of them are going to be negative. And that means that y will be negative. We've got a negative divided by a negative times a negative. Overall, that's going to be negative. As soon as x is more than negative 4, this one becomes positive. The other two are still negative, so overall that's positive. Between 0 and 4, this one is positive, this one is positive, but the other one's still negative. So overall negative. And when x is more than 4, all three parts of the function will be positive, so overall y will be positive. So let's try to put everything together in a sketch. So we'll have the x-axis along here and the y-axis here, and then we have vertical asymptotes, say here and here. So this one is x equals 4, this one is x equals negative 4. We know, let's do the curve in a different colour, that it goes through the origin here. Now let's look at this region over here. We know that y is negative, so it's going to be below the x-axis. When x is very close to negative 4, the denominator is going to be close to 0, so we're going to go off to negative infinity down here. But when x becomes very large, the bottom is going to be much bigger than the top, so it's going to tend to 0. And remember, it's always going to be negative, as we can see from our table analysis. If we look at the region over here, then we know that y is positive. When x is very close to 4, the denominator is close to 0, so it must go off to infinity along this asymptote, and then as x gets bigger, overall we get closer to 0. So that's going to look like that. What about this region here? We can see that it's positive, so that's going to be above the axis. It's going to go to the asymptote up here, and then it's going to come down, and it must go through here. Then in this region just here, between 0 and 4, it's negative. It's going to go off along the asymptote, so it's going to not look like that, but it's going to look very much like the bit above, so it's going to go like that. Now we should always label anything that we've drawn, so y equals x over x squared minus 16. And I have an accurate plot of the graph here. And we can see that it exhibits all the features that I have in my sketch.